Hi guys, welcome to Scholars GS Prelims classes. Myself Biswajit Sir, your faculty for Geography. So in the last class we talked about your igneous rocks, right? So today we'll continue with the topic of rocks and go on to discuss about your sedimentary rocks and metamorphic rocks along with your rock cycle.
Alright, so in this class the first thing that we are going to talk about is your sedimentary rocks. Then we'll go on to understand the metamorphic rocks, and finally we'll understand what a rock cycle is, and then conclude this session by looking into different questions. Fine. So the first thing that we'll talk about is your what are sedimentary rocks. So what are these rocks? So sedimentary rocks are formed by successive deposition of sediments. So how are sedimentary rocks formed? They are formed by the process of deposition of what? Deposition of sediments. So what are sediments? Sediments are naturally occurring particles which are derived by the process of weathering and erosion of pre-existing rocks. So in rocks what will happen? If this is a rock, in this rock what will act? The process of weathering and erosion will act on this rock, and because of this what will happen? Because of this, these rocks will get broken down into different fragments. Fine, and these fragments are called as sediments. Understood what sediments are? So sediments are nothing but rock fragments. And how do we get those rock fragments? We are getting them because in the rock what is acting? Weathering and erosion process, and because of weathering and erosion the rock is broken down into several fragments, and these fragments are called as your sediments. Fine. So these sediments may be debris eroded from previous existing rock, which may be igneous, metamorphic or old sedimentary rock. What does this mean? Now this rock that you see here, what can be this rock? This can be igneous rock, this can also be metamorphic rock, or this can also be your old sedimentary rocks. Understood this point? So what is your origin of sedimentary rock? So the origin of sedimentary rock is sediments, right? And where are we getting those sediments from? We are getting those sediments from rocks. What type of rocks? Igneous rock, metamorphic rock, as well as old metamorphic rocks. So we can state that the origin of sedimentary rocks can be igneous rock, metamorphic rock, as well as old sedimentary rocks. Understood this point? Then what was the source of origin of your igneous rock? The source of origin of igneous rock was your magma, right? If you remember. So this is the contrasting picture between igneous and sedimentary rocks. Igneous rock, origin magma, and what is the origin of sedimentary rocks? Igneous, metamorphic, as well as old sedimentary rocks. Understood this point? So the process of successive deposition and formation of sedimentary rock is called as lithification. So what is lithification? Lithification is nothing but, you see these sediments here or rock fragments. These rock fragments under the process of compaction plus compression will lead to formation of rocks. Understood this point? So these fragments we get from where? We get from the process of erosion and weathering, right? So this process, so what is acting on these rocks? The first thing that is acting is your process of erosion and weathering. So after this, what is happening to these fragments? These fragments will now come together and it will get compacted. So the sediments are coming together, it is getting compacted and compressed, and under the process of compaction and compression, it will result in formation of sedimentary rocks. Understood this process? Fine. Alright. So this type of rocks cover 75% of the earth crust, but volumetrically occupies only 5%. Alright. So it may cover the earth's surface by 75%, but volumetrically what is its percentage? It is only 5%, which is the least. Understood? Now let us talk about basic characteristics. So what are the basic characteristics of sedimentary rock? First thing is that it is fossiliferous, meaning what? This kind of rocks will have fossils in them. Unlike igneous rock, in case of igneous rock, what was the case? Igneous rocks were non-fossiliferous, right? Understood? Or there were no fossils in igneous rock, but sedimentary rocks will have fossils in them. Next, it is highly stratified, meaning what? It will have presence of different layers, or stratification is present. Understood this point? Now what about igneous rock? igneous rock was non-stratified, if you remember. Understood the difference between both of them? Fine. Thirdly, it is non-crystalline in nature. However, correspondingly, what was your igneous rock? Igneous rock was having crystalline structure, right? Understood the difference in the characteristics of igneous and sedimentary? Fine. Now, based on the mode of formation or based on the process of formation of sedimentary rocks, it is classified into three different categories. One is called as a mechanically formed, second one is called as a organically formed, and third one is called as a chemically formed. By the process of mechanically formed, we get different types of sedimentary rocks. First one is called as a sandstone, then we get conglomerates, then we get limestone, then we get shale as well as loess. And organically formed, what are the examples of organically formed sedimentary rocks? It can be geyserite, chalk, limestone, coal. And in case of chemically formed, examples would be limestone, halite and potash. So here what do we see? We see that the limestone, alright, the rock limestone can be formed both organically as well as chemically. Fine, understood till now? Fine. Now let us look at each one of these process individually. So the first one that we look into is your mechanically formed. Now these mechanically formed sedimentary rocks, remember, they are also called as your clastic rocks. Now why are they called clastic rocks? They are known as clastic sedimentary rocks because of their formation by accumulation of clasts. They are called as clastic rocks because they are made up of clasts. Now what are clasts? Clasts are nothing but little fragments of broken up rock material which gets piled up and lithified by compaction and cementation. Understood? So what are clasts? Clasts are nothing but rock fragments, or these can also be called as sediments, right? So these sediments under the process of compaction, cementation and compression will result in the formation of clastic sedimentary rocks. Fine, understood this point? Okay, now what are the examples of mechanically formed? First one is just sandstone. Now this sandstone is forming by the process of lithification, right? Lithification of what kind of sediments? By the lithification of sand particles. Understood this point? So these sand particles under the process of lithification will result in formation of sandstone. Next example is shale. Shale is formed by the process of lithification of clay. Also silt can also be written here. It is formed by both the lithification of clay and silt. Fine. Next we have conglomerates. Conglomerates is formed by cementation of rounded pebbles. So rounded fragments, when they undergo the process of cementation, it will result in formation of what kind of rocks? Conglomerates. Fine. Lastly we have breccia. Now the major difference between conglomerate and breccia is that conglomerate is made up of rounded particles, cementation of rounded particles, but in case of breccia, it is formed by the process of cementation of angular fragments. Understood these different types? Sandstone formed from sand particles, shale from clay and silt, conglomerates from rounded pebbles, and breccia from angular fragments. Fine. So this is all about your mechanically formed sedimentary rocks. Now let's talk about what is organically formed. So the remains of plants and animals are buried under the sediments, and under the process of heat and pressure from the overlying layers, their composition will change, and depending upon the content of calcium or carbon, these sedimentary rocks are classified into calcareous and carbonaceous. Understood this point? So what is organically formed sedimentary rocks? So the remains of plants and animals which are buried under the sediments will go what? Under the heat and pressure will go changes in their chemical composition as well as physical composition, right? So based on this, what kind of rocks we are getting? We are getting organically formed sedimentary rocks, and they are classified into two different categories. First one is called calcareous and another one is called as carbonaceous. Now what is the difference between calcareous and carbonaceous? In calcareous, what is happening? Your content of calcium is very high, and hence the name calcareous. And in carbonaceous, what is happening? The content of carbon is very high. Understood the difference? Now what are the examples of calcareous organically formed sedimentary rocks? It will be limestone. And from where are we getting limestone? From these skeletal fragments of marine organisms. Understood this point? So these skeletal fragments that you see here, when it falls below the lower layers or when it comes below the earth's surface, what is happening? It is coming under increasing temperature and increasing pressure, right? Because of this, these fragments that you see here, skeletal fragments, what will happen to this? It will undergo physical and chemical changes under heat and pressure, which will in turn result in formation of your organically formed sedimentary rocks. Fine. Next we have chalk. Now what is chalk made up of? It is made up of 99% calcium carbonate. Then we also have dolomite. Dolomite is made up of calcium magnesium carbonate. Fine. What can be your example of carbonaceous sedimentary rock? The most important example is your coal. So how does coal form? Now if you remember the topic of continental drift theory, what did I say? We also mentioned about the formation of coal, right? Because coal is found where? Coal is found in your, coal can be found in what kind of climate? It can be formed in climate which is hot and humid, right? But we have presence of coal in temperate regions. How so? Because the continents were drifting, right? So how does coal form? Now suppose this is a rock layer, right? And above this rock layer we have presence of vegetation, right? So what is happening in due course of time? In due course of time, suppose the middle portion of this rock layer has undergone subduction, and because of this subduction, what will happen? This vegetation that you see here, it falls below, right? It falls down because of subduction. So this vegetation that you see here will now come under increasing heat, that is temperature, as well as increasing pressure, and under this increasing temperature and increasing pressure, this vegetation that you see here, what will happen? It will undergo chemical and physical changes, resulting in formation of what kind of rock? We get coal. Understood how we get coal? Fine. So this is about your organically formed sedimentary rock. Next and the last type of process of formation is called as your chemically formed. So these sedimentary rocks form when mineral content in solution becomes supersaturated and inorganically precipitates. Understood this point? Fine. Now what are the examples of chemically formed sedimentary rocks? First will be your rock salt. From where are we getting rock salt? It is derived from old sea bed or lakes. Then we have gypsum, which is formed from evaporation of salt lakes. Then we also have potash and nitrate by the same process of evaporation. Then we have stalactites and stalagmites. Now you see these terms, stalactites and stalagmites. What are these? So these are nothing but deposits of lime which are found in underground caves. Now suppose this is a cave here. Inside this cave we get different structures like this. And these structures that you see here, this structure which is present in the upper layer, these are called as what? These are called as stalactites. And these lower elevations that you see here, they are called as stalagmites. And this is what? This is an underground cave. Fine. So what are these stalactites and stalagmites? These are nothing but deposits of lime. So at one point of time, what was happening? Water which was present above these caves here, water was present here, right? So this water will what happen? It will percolate below. It will percolate below to the lower layers. So this water is carrying what? This water is carrying lime, right? So in due course of time, what is happening? The water content, what will happen to it? It will evaporate, leaving behind only lime. So what happens? It results in solidification. So when your water moves away or water evaporates, it only leaves behind lime, right? So these structures that you see here, these are nothing but deposits of lime when water evaporates, and these are called as your stalactites and stalagmites. Now we will talk about these stalactites and stalagmites in a new topic which is called as your karst topography, and this is very, very important for your examination perspective. So this kind of structure that you see here, stalactite, stalagmite, underground cave, this whole structure forms under a topography or a relief feature which is called as your karst topography. So this is a complete different chapter which we'll deal with once we proceed with the module 1, which is your geomorphology. Fine. Understood what are stalactites and stalagmites? Alright. Fine. Now let us talk about where in India do we find the presence of sedimentary rocks. Firstly, we find alluvial deposits in the Indo-Gangetic plain and the coastal plains of India, right? This can also include your what? In the Brahmaputra plain areas as well. Fine. First, alluvial deposits in Indo-Gangetic plain, coastal plains of India as well as your Brahmaputra plain areas. Then we have different varieties of sandstone which are found in Madhya Pradesh, eastern Rajasthan, parts of Himalaya, Andhra Pradesh, Bihar and Odisha as well. Then the Vindhya range in central India, which consists of sandstone, shales, limestone. Then we have coal deposits which occur in river basins of Damodar, Mahanadi, Godavari. These are what? These are rivers of peninsular India, right? Fine. So these are the areas where we find presence of sedimentary rocks in India. Fine. So this is where your topic of sedimentary rock ends. So moving on from the sedimentary rocks, okay, before ending this topic, let us also talk about the economic significance of sedimentary rocks, or why sedimentary rocks are important. Firstly, minerals such as hematite iron ore, phosphate, building stones, coals, petroleum and materials, and this kind of materials are used in cements are also found. That means sedimentary rocks will include what? It will include hematite ore, phosphates, building stones, coals, petroleum as well as materials which are used in your cement industries. Fine. The decay of tiny marine organisms yield petroleum. So what is the source of petroleum? The source of petroleum is your marine organisms. So these marine organisms are what is happening to this? These will be what type of sedimentary rock? These will be organically formed sedimentary rocks or not? Because these marine organisms, what is happening to them? It is coming under extreme temperature and pressure, resulting in changes in its chemical and physical composition, right? Resulting in formation of organically formed sedimentary rocks. And these sedimentary rocks are source of what? These are sources of oil and petroleum. Fine. Then minerals like bauxite, manganese, tin are derived from other rocks but are found in gravels and sands also. Understood this point? So bauxite, manganese, tin are derived from other rocks like igneous rocks. Fine. But these are also found in gravels and sandstones, which are examples of sedimentary rocks. Then sedimentary rocks also yield rich soils as well. Understood the economic significance of sedimentary rocks? Fine. Alright. Next, we'll talk about the metamorphic rock. Okay. What is metamorphic rock? The word metamorphic itself means change of form. Hence, these rocks form under the action of temperature and pressure and volume changes on original rock. What is happening? When rocks or when original rocks come under the role of temperature, pressure, or come under the process of changes in temperature, pressure as volume changes, it will result in formation of metamorphic rocks. Understood till now? Fine. So metamorphic rocks are formed under the influence of heat or pressure on original rocks, which cause to change their color, hardness, structure and composition. So rocks, when they are coming under the influence of heat and pressure, it will result in formation of metamorphic rocks, or it would result in change in their color, hardness, structure and composition. Fine. So the process of recrystallization and reorganization of materials within the original rock is called as metamorphism. Understood? So here we have a rock. When these rocks are getting converted into metamorphic rocks, under what process it is getting converted into metamorphic rocks? Under the process of metamorphism. And why do we have metamorphism? We get metamorphism because of the influence of heat and pressure, right? So rocks become metamorphic rocks by the process of metamorphism, and metamorphism happens because of your role of heat and pressure or temperature and pressure. Fine. So what are the causes of metamorphism, or why metamorphism occurs? First one is called as your tectonic activities. Because of tectonic plate movements, rocks may move to the lower layers, which brings them under immense pressure from the above layers. This is metamorphism. Okay, this can be understood by an example. Tectonic activities. Now again, go back to your plate tectonics theory. In plate tectonics theory, we talked about the convergence of plate, right? See, convergence of plates means what? These two plates are moving towards each other. Now suppose this is the continental plate and this is an oceanic plate. Which one is denser? Oceanic floor is denser, right? So this oceanic floor, once it collides with your continental floor, what will happen? The oceanic floor will move down because it is denser, right? Remember? So as this move down, what is happening? this area that you see here will come in under the influence of increasing pressure as well as increasing temperature, right? So this will cause changes for inward. So here we have presence of rocks or not. So these rocks now are coming under increasing role of pressure and temperature, resulting in formation of what type of rocks? Metamorphic rocks. So suppose here we had the presence of igneous rock, or here we had the presence of sedimentary rocks. So these igneous rocks, sedimentary rocks are coming under the increasing role of temperature and pressure. So this igneous rock or sedimentary rocks are getting converted into metamorphic rocks under the process of metamorphism. Fine. So this is your tectonic activity. This is the first cause of metamorphism. Second cause of metamorphism can be your volcanic eruptions. So in areas of volcanic eruptions, what is happening? When magma intrudes the earth's crust, causing volcanic eruption, rock in these areas come under immense heat, causing crystallization or metamorphism. Meaning what? Now suppose this is the earth crust. From below we are having the magma intrusion, right? So as magma intrudes the earth crust, magma will flow here in both the direction. So if you see here, in these areas we will have rocks or not. So these rocks are coming in contact with the magma. When it comes in contact with the magma, what is happening to these rocks? In these rocks will not come under the influence of increasing temperature, right? Because magma is hot, right? So these rocks which is present in the adjacent areas of these volcanic regions, this will come under increasing temperature, and increasing temperature will result in what? Result in metamorphism, causing the formation of metamorphic rocks. Understood this? So what are the two important causes of metamorphism? Tectonic activities, and second one is your volcanic eruption, right? So based upon these different causes, we get different types of metamorphism. And the first type of metamorphism is called as a dynamic metamorphism. Now what is dynamic metamorphism? See, in metamorphism we have two important agents of changes, right? Or two important agents of metamorphism. What are these? These are temperature and pressure. So in case of dynamic metamorphism, the most dominant role is played by the pressure. So we have two types. One is called as dynamic metamorphism and another one is called as your thermal metamorphism. So thermal term itself means temperature. So in case of thermal metamorphism, what is the dominant role? The dominant role is being played by temperature. But in case of dynamic metamorphism, who is playing the significant role? It is the pressure. So this refers to formation of metamorphic rocks under high pressure. So sometimes high pressure. Okay, before moving into this point, now how we are getting high pressure? Firstly, we talked about the tectonic activities, right? Fine. So in tectonic activities, what is happening? When rocks move to the lower layers, when rocks are moving to the lower layers, so this is a lower layer, this is an upper layer. Fine. So this upper layer, will it not exert a pressure on the lower layers? Right? So because of tectonic activity, what was happening? The ocean floor moved below, right? So now the oceanic floor, which is consisting of igneous and sedimentary rocks, will it not come now under the continental plate? So now the continental plate will be present above and the oceanic floor will be present below. So this is the upper layer. For example, consider this to be the continental plate and consider this to be a oceanic plate. So this oceanic plate is now coming under increasing pressure from the continental plate or not, right? As a result of this, what will happen in these lower layers? It will be under increasing pressure, and this increasing pressure will result in metamorphism and we'll get dynamic metamorphism. Understood this point? Fine. Now sometimes high pressure is accompanied by high temperatures and the action of chemically charged water. So along with high pressure in the lower layers, when the rocks move below the lower layers or moves to the lower layers, along with increasing pressure, we will have also increasing temperature. Fine. Understood this point? Because as we move from the surface of the earth to the lower layers, temperature is increasing. So pressure is also increasing, your temperature is also increasing, and this kind of phenomena is called as your dynamo-thermal metamorphism. Dynamo means pressure, thermal means temperature. That means both pressure and temperature is playing a role, and hence the term dynamo-thermal metamorphism. One more point, along with pressure and temperature, metamorphism can also be caused by chemically charged water. If you remember water can be considered as a weak acid as well. Meaning the water which is present in the oceans are not neutral, but rather it is a weak acid. So they can also cause metamorphism up to a certain extent, but the major role is played by pressure and temperature. Understood? So the combination of direct pressure and heat is very powerful in producing metamorphism because it leads to more or less complete recrystallization of rocks and the production of new structures, and that phenomena is called as your dynamothermal metamorphism. Fine. Next, what is thermal metamorphism? Due to thermal stress, the material of rocks undergo crystal transformation, which alters the chemical properties of the rock. So these are two types. So there are two types of thermal metamorphism. So in thermal metamorphism, what plays the more dominant role? It is the temperature which is playing the dominant role. And thermal metamorphism are of two types. One is called as a contact metamorphism and another one is called as a regional metamorphism. Fine. So what is contact metamorphism? Rocks come in contact with the hot intruding magma and lava, and the rock materials recrystallize under high temperature. I have already explained contact metamorphism, right? Volcanic eruption, magma intrusion. We will have a volcano here, and these rocks that are found in these areas, what will happen to this? These will come under increasing temperature, resulting in metamorphism or formation of metamorphic rocks. Fine. Then we'll have another type which is called as a regional metamorphism. What is regional metamorphism? Recrystallization of rock takes place as a result of deformation caused by tectonic shearing along with high pressure and temperature. So what is tectonic shearing? Tectonic shearing is nothing but if you go to the convergent boundary in the plate tectonics theory, how many types of convergent boundaries were there? There was how many types of boundaries were there? First there was convergent boundary, which was of OO collision, OC collision, CC collision. Then we had divergent boundary resulting in formation of modes. Then we had another type of boundary. Three types of boundary intersections were there, right? Convergent, divergent, and another one is called as your transform boundary. What was a transform boundary? Transform boundary is those areas where the tectonic plates are moving past each other. They are neither colliding, neither moving away from each other, but rather it is sliding past each other. And what was the example? What was an important example? It was San Andreas. If you go back to the chapter of plate tectonics theory, fine, which is found along which coast of America? It is found along near west coast of America. Fine. So in these areas where the tectonic plates are sliding past each other, these will come under the role of increasing pressure and temperature, causing regional metamorphism. Understood the difference between contact metamorphism and regional? Fine. Okay. Now in case of metamorphic rocks, there are two important terminologies. First one is called as foliation or lineation. The second one is called as a banding. So what is foliation or lineation? In the process of metamorphism, in some rock grains or minerals get arranged in layers or lines. This arrangement is called as a foliation or lineation. That means what? In this case, in metamorphic rocks, the rocks or the minerals are getting formed in different layers or stratifications are present, right? And these layers are called as, or this type of structure is called as foliation, or the process is called as foliation or lineation. Understood this part? What is foliation? Then what is banding? Sometimes minerals or materials of different groups are arranged into alternating thin to thick layers appearing in light and dark shades. Meaning what? Meaning that sometimes metamorphic rocks which are occurring in layers, sometimes it is occurring in the form of a thick layer and a thin layer. So giving us a appearance of light color then dark color, light color, dark color. Understood this point? So suppose this is a thick layer, this thick layer will be dark in color. Upper layer, this is thicker, right? This is thinner, this is thicker. Upper layer will be light in color. Then this is again a thick layer which will be light in color. Then again we'll get a thin layer which will be dark in color. Then again we'll get a layer which is thick and we'll get a light in color. So we are getting bands or alternating bands which are thick, thin, right? That means we are getting bands having an appearance of light color, light color, dark color, or alternatively we are having light and dark color. Understood? So that kind of structures are called as banding. So that is the major difference between the foliation and banding. Foliation is formation of different stratifications, formation of layers, and banding is layers alternatively having dark and lighter color or having thickness and thinness. Understood? Fine. So what are examples of metamorphic rocks? Now this is very important. Okay, now granite is what kind of rock? Granite is an igneous rock, right? So this igneous rock under the role of pressure will get converted into gneiss. Under the role of pressure means what? Under the dynamic metamorphism. Kindly remember, this is very, very important. This chart is very, very important. So granite under dynamic metamorphism will get converted into gneiss. Then clay and shale, which are type of what kind of rocks? These are sedimentary rocks, right? Under dynamic metamorphism, pressure will get converted into schist. Then we have sandstone, which is a sedimentary rock. So this sedimentary rock under heat will get converted into quartzite. Heat means what kind of metamorphism? Thermal metamorphism. Then again clay and shale under thermal metamorphism will convert into slate, and slate will get converted into phyllite. Now these two examples are very, very important. Clay and shale under dynamic metamorphism, that is pressure, is getting converted into schist, but under thermal metamorphism it is getting converted into slate and phyllite. Okay, this is very, very important. Schist, slate and phyllite. Schist we get when dynamic metamorphism is happening, we get slate and phyllite when thermal metamorphism happening. Understood? Then we get coal. Coal is again an example of sedimentary rock, right? Under thermal metamorphism it is getting converted into anthracite, and finally we get graphite. Then we have limestone, which is an example of both what? It is an example of both organically formed and chemically formed sedimentary rocks. Under thermal metamorphism it is getting converted into marble. Understood? So where in India do we find the presence of metamorphic rocks? Metamorphic rocks like gneiss and sheets are found in the Himalayas. It is found in Assam, West Bengal, Bihar, Odisha, Madhya Pradesh, Rajasthan. Then we have quartzite, which is found in Rajasthan, Bihar, Madhya Pradesh, Tamil Nadu and areas surrounding Delhi. Then we get marble in areas like Rajasthan, Narmada Valley in Madhya Pradesh. Then we get slate in the areas like Haryana, Himachal and parts of Bihar. Then we get graphite as well in areas like Odisha and Andhra Pradesh, right? So this was about your metamorphic rocks. Now the last topic for today is your rock cycle. What is a rock cycle? Like most earth materials, rocks are created and destroyed in natural cycles. So rocks do not remain in their original form for a very, very long time. So what is happening to rocks? On one hand, rocks are getting formed, and on the other hand, rocks are getting destroyed. And these destroyed rocks will again result in formation of rocks. So what is happening to rocks? Rocks are getting formed and rocks are getting destroyed. Again, destruction will again lead to formation. Formation will again lead to destruction. So there is a cyclic process. Understood this point? So this rock cycle is a model that describes the formation, breakdown and reformation of a rock. First the rock is formed, it is getting destroyed. Now destruction will lead to again reformation. This reformation will lead to again resulting in formation of rocks. Again these rocks will get destroyed, again reform, again form. Understood? So a cyclical process is happening. So the rock cycle is a model that describes the formation, breakdown and reformation of a rock as a result of sedimentary, igneous and metamorphic processes. So rock cycle is a continuous process transforming old rocks into new ones. Understood this point? Now if you look into this diagram, see what is happening to igneous rock. Igneous rock under the process of weathering and deposition is getting converted into sediments. The first topic. After the sediments, what is happening to the sediments? Sediments under the process of lithification will get converted into what kind of rock? Into sedimentary rock, right? Because lithification is a process which is associated with what? It is associated with sedimentary rock. So from igneous rock, what are we getting? From igneous rock, we got sedimentary rocks, right? Similarly, sedimentary rocks under the role of heat and pressure will get converted into metamorphic rocks. So sedimentary rocks, so from sedimentary, we are getting metamorphic rocks. Again, metamorphic rocks, when it melts, we get magma. And when this magma is crystallizing, we are getting igneous rock. So from metamorphic rocks, we can also get what kind of rock? Igneous rock. Understood this point? So it's a cyclical process. From igneous we can get sedimentary, from sedimentary we can get metamorphic, from metamorphic we can get igneous. So this process keeps on going, and this cyclical process is called as rock cycle. That means what? It's a continuous process transforming old rocks into new ones. Understood this point? So this is where your class ends. So before concluding with questions, let us do a quick revision within a minute. So what did we learn today? The first thing we talked about your sedimentary rocks, right? Sedimentary rocks are formed by sediments, and how are we getting those sediments? Under the process of weathering and erosion acting on rocks, we get fragments, and these fragments are called as sediments. And these sediments under the process of lithification results in formation of sedimentary rocks, right? So what is the basic characteristic? It is fossiliferous, it is highly stratified, as well as it is non-crystalline. And what is the mode of formation? There are three different modes of formation. First one is called mechanically formed, then organically formed, chemically formed. Here I also mentioned that limestone can be formed both organically and chemically, right? Now, mechanically formed rocks are also called as clastic rocks. And what are the examples? We have sandstones, shale, conglomerates, and breccia. Then we have organically formed, which are classified into two parts, that is your calcareous and carbonaceous. Carbonaceous would include your coal, and calcareous would include limestone, chalk, and dolomite. Then we'll have chemically formed, which is formed by the process of supersaturation and inorganic precipitation of what? Of mineral constituents. Example would be your rock salt, gypsum, nitrate, then potash, stalactite and stalagmites. Stalactites and stalagmites are deposits of lime in the underground caves, and the whole topography is called as a karst topography, which we'll talk about in the later classes. Then we have sedimentary rocks in India. Where it is found in Brahmaputra plain, Indo-Gangetic plain, and other areas like the central India mostly. Fine. Then we talked about the economic significance. We get different minerals, we get oil and gas and petroleum also. It also from rich soils. Fine. Then we talked about metamorphic rocks. What is metamorphism? Metamorphism happens because of increasing temperature and pressure, right? Metamorphism, there are two reasons. One is called tectonic activities and volcanic eruptions, which we talked about. Then we also talked about different types of metamorphism. Dynamic metamorphism, which is because of pressure. Then we talked about dynamothermal metamorphism as well, how both pressure and temperature is playing a role. Then we also talked about your thermal metamorphism, where temperature is playing a more dominant role, and thermal metamorphism are of again two types: contact metamorphism and regional metamorphism, right? In case of contact, it was because of contact with magma, and in case of regional metamorphism, it is because of tectonic shearing or transform faults, like the San Andreas in the west coast of America. Then in metamorphic rocks, we find two different types of structures. One is called as foliation or lineation, and another one is called as banding. Foliation means formation of different layers, and banding means formation of alternate bands of dark and light or thick or thin layers. Fine. Alright. Well, now what are the different examples of rocks? In this case, we talked about gneiss, schist, quartzite, slate, phyllite, marble, anthracite. Here, the most important example is your clay and shale, which are sedimentary rocks, which under dynamic metamorphism is getting converted into schist, but under thermal metamorphism, it is getting converted into slate and phyllite. Fine. Finally, we talked about the metamorphic rocks in India as well, like where in which areas it is found. Then we talked lastly about the rock cycle, how the old rocks are getting converted into new rocks, right? How it's a cyclical process, how from igneous we get metamorphic, from metamorphic we get sedimentary, and this process keeps on changing, right? It is an interchanging process. From one rock we can get two other rocks, from two other rocks we can get one rock. So this is a cyclical process where one rock from where old rock is getting converted into new ones, and that phenomena or this cyclical process is called as your rock cycle. Fine. So this is what we learned today.
Hi guys, I hope you understood the topic of rocks, where we talked about your different types of rocks like igneous rock, metamorphic rocks, and sedimentary rocks. Then we also went on to understand what a rock cycle is. So in the next class, we'll delve into a new topic, and the name of that topic is your geomorphic processes, where we will specifically talk about endogenetic movements or processes. So stay tuned to Scholars for more such content.